Hello everyone. In this video, we discuss the very important lesson in chemistry is chemical equations. In your previous classes, you have learned what are the different types of changes, right? Physical changes, chemical changes, you have discussed. Now, let us see chemical changes. In this video, we discuss about chemical changes. So, we say chemical change. We see various chemical changes in our daily life, like the chemical changes like we see respiration, respiration, burning of burning of LPG, photosynthesis, photosynthesis, like rusting of iron, like many changes we see in our daily life, right? All these changes are actually chemical changes. Why are these called chemical changes? You have already learned in your previous classes. Why are these called chemical changes? Because in every reaction, every chemical change, okay, that takes place here, in every change, always one substance undergoes a change into and produce a new substances with completely different set of properties. Okay, for example, respiration. During respiration, what happens generally? The glucose in the body is converted into carbon dioxide and oxygen. Glucose on oxidation, okay, produces CO2 and O2 as a result of respiration in the body. Burning of LPG, whenever LPG is burnt, it undergoes, okay, it reacts with oxygen and it produces CO2 and H2O. New substances, photosynthesis. In photosynthesis also, new substances produced. We know photosynthesis, it's a process of making food by plants. Here, plants use CO2 and water to produce glucose, to produce glucose, and what is we get? We get oxygen. They are the new substances that are produced during a photosynthesis. Lastly, rusting of iron. Okay, we know new iron, when it is exposed to air and water, especially, we can use a moisture in the form moisture. It gives us generally rusted iron. So rusted iron used to get during this. So in all these changes, if you see, okay, in every change, a new substances are produced and their properties are completely different. You can see glucose, right? And that produces two gases, CO2 and uh, so CO2 and glucose undergoes oxidation and it produces uh, right, CO2 and water vapor. Water vapor is produced as a result of respiration. Water vapor is produced, right? Whenever LPG is burnt. As a result of burning, it produces carbon dioxide and water. And during photosynthesis, CO2 and H2O from the atmosphere is taken to produce glucose. Glucose is in the form of food, right, to the plants. Finally, rusting of iron. Rusting of iron, see, new iron nail, how it is. And after a change, it become rusted. So these all are, we get substances which are entirely new, right? They have completely different properties that of a previous ones, right? If we understand that they all have undergone, right, a chemical change, right? And these chemical changes, let us see some other chemical changes. Let's see some activities. What are the, to understand indications of a chemical change? Let us see. Let's discuss an activity. In an activity, right, when lime, right, we have we used to say it's a quick lime. Quick lime, right, is added to water, added to water. Quick lime, lime, for why this is this quick lime in the powder form is used for whitewashing walls, right? And that quicklime is added to water. Okay, so what changes? What changes do we notice, right? When quicklime is added to water, what changes do you see? Let's see. I generally take I take a beaker. That's right. I take a beaker, right? To this, some water, some quicklime is added. It's like, let's say it's a lime. It's a quicklime is added, and to this, add some water. This is water. Add some water. So quicklime is added to water. What happens? So we see this quicklime, it dissolves. This quicklime dissolves in water and form a solution. Form a solution, right? And what else? What other changes? If you, when it is dissolved, if you touch this beaker, if you touch the beaker, we feel the beaker, it warm, it become warmer, okay, than the previous case. Like, it become warmer. So how does it gets that heat? Because whenever quicklime dissolves in water, it makes a solution, and when this reaction happens, the amount of heat energy is released. Heat energy is released. So because of that heat energy, when you touch, we feel hot. Okay, heat energy is given out. So during a chemical change, it's a chemical change. When quicklime is added to water, we get a solution called lime water, and along with some heat energy is also produced, right? This heat energy, right, is released. Such reactions are called, we call such reactions are exothermic reactions. Exothermic, right? The reactions in which heat energy is given out. So there is a change in energy when reactants, when substances react with each other. So what are the substances here? Water and quicklime. They, when they react with each other, there is a change in energy. This is one. Let's discuss another activity. Let's discuss another activity. Let's say this is activity 2. Let's make a, let us see here. In this case, let us take some, let's add a small quantity of barium chloride. You learnt in the previous classes how to write formula of barium chloride. Barium chloride. So barium chloride. Take small quantity of barium chloride, add it to 100 ml of water. 100 ml of water. We get a colorless solution. We get a colorless solution of barium chloride. Barium chloride, right? Then next, we take sodium sulfate. Sodium sulfate, Na2SO4, right? Sodium sulfate. Take small quantity of sodium sulfate, add it to 100 ml of water. Then we get again a colorless solution, of sodium sulfate, Na2SO4. We get a clearly. So we have two solutions. One is a barium chloride solution and sodium sulfate solution. Both are soluble. These two are soluble salts, soluble compounds. Let me write. They are soluble compounds. When they added to water, they dissolve to give a colorless solutions. Now what I do, I take this barium chloride solution. It's like I take a beaker. I take a beaker. Let's say this beaker contains barium chloride solution, right? And I just transfer, okay, another solution, okay, into this. And this solution, let's say this is a sodium sulfate solution, Na2SO4 solution, right? This is sodium sulfate solution. So when you add these two solutions each other, immediately we see like this is initially it was a colorless solution. It was a colorless solution, but when these two solutions are added, we see A precipitate, a formation of a precipitate. Precipitate is formed. Okay, a white color substance is formed. What is it? This is white color, white color substance. White color substance was not there. It was not there earlier. Two solutions are of colorless solutions, but these colorless solutions on mixing with each other, they gave a white color substance, which is we see a white color substance, a new substance formed. It's a new substance formed. Okay, so this the formed white color substance is being insoluble in water. It's being insoluble in water, and such substances we generally say precipitates. This is a precipitates. Okay, precipitates are generally represented by PPT, precipitates. So here a white color substance, a precipitate is formed. So now during such changes, this is also a chemical change, indication of chemical change. How can we take it as indication? Because during this reaction a new substance is formed, a new substance, an insoluble substance, white precipitate is clearly observed, a new substance formed. So we can consider this is also an example of a chemical change. Let's see another example of to identify chemical change. Let's make another activity. Let's discuss another activity, activity 3. So in this activity, what shall we do? We take a, let me take a conical flask, right? This is, I draw, this is, we take, this is called a conical flask. It's a conical flask, right? Then in this conical flask, in this conical flask, let's take a dilute acid. Let's take a dilute acid. What is it? It's, let's say, it's dilute hydrochloric acid. Dilute hydrochloric acid, right? Now what I do, I add a piece of metal, a piece of metal. Okay, which metal this is? Let's say this is a zinc metal, zinc granule. If I add a zinc granule to it, what happens? We see immediately soon after you add zinc granule to acid like hydrochloric acid, you see the evolution of a gas, evolution of gas. You see, this is all, let's say, dilute acid, and in this acid we see evolution of gases. Okay, and this gas, okay, which was not there earlier, this is a, what say, evolution of a colorless gas, evolution of a colorless gas. So a colorless gas is released, right? Whenever this gas was not there before you add this metal sample to acid, right? Acid is a colorless solution, right? We have a metal, zinc metal, its color is metallic gray. When it is added, a gas is released, a gas, okay, which was not there. This is a new substance here, this is a new substance here, right? Now using these three activities from the observations, what do we conclude? In all these cases chemical change has taken place, and what are the indications, right? In a first activity, where in first activity lime is added to water, quick lime powder is added to water, right? What happened when we touch the beaker? It gets warmer, it gets hot. Okay, so there is a change in heat energy as a, like, during a chemical change. Next, in activity 2, what happened? When two colorless solutions are added, right, we get a precipitate, a new substance, a precipitate is formed. And a third activity, gases are released. What are these all? These all are the, right, indications of a chemical change. Let us write these three indications, right, during a chemical change, right? Chemical changes are accompanied by, or during chemical change, during chemical change, there may be, change in heat energy, heat energy either absorbed or released. This is one. Then during chemical reactions, what happen? Precipitates may form, precipitates may be formed, right? And during chemical change, gases released, gases may be released. Okay, during chemical changes, what there is a change in heat energy, precipitates gases, like new substances are formed. New substances are formed with different properties, with different properties. So these are the 4 points we say indications during a chemical change. So that these changes indicate us that the change is chemical change. We understand. Now, how do we represent the chemical change in all the cases, right? Now, to represent shorthand representation, shorthand representation of a chemical change, shorthand representation of a chemical change. What is it called? It's called a chemical equation. It's called chemical equation. So now example 1. So the activity that we have seen like earlier, that was adding lime to the water. So what did I do? Added lime. So I added lime to water and I get lime water. I get lime water, right? I get lime water, right? These are the reactants. This is a product. What are these? These two are called reactants. Reactants. What are reactants? The substances that undergoes change, that undergoes change are called reactants. So lime and water when added with each other, they are reacting with each other, undergoing a change, and they are called reactants. When two or more reactants are there, they are separated by plus sign. Then this is the new substances formed. It's called products. It's called a product. If products are also two or more, we can write them using a separating plus sign. Okay, lime water plus something else if anything releases. In this case, only lime water is the only product in this change. Now, this is a what is it? So instead of words, I have written chemical equation, chemical change. Whatever lime reacted with water, that chemical change is represented in a shorthand way. Okay, but we can make this chemical equation still precise. We can still reduce. We can still precise the writing chemical equation by using their formula, chemical formula of all the reactants and the products. So I use, let's write lime, quick lime, right? Just write quick lime. So quick lime is actually, what is it on? It's a calcium oxide. It's calcium oxide. Its formula, its chemical formula is CaO. Calcium oxide is treated with water, produces lime water. Lime water formula is calcium hydroxide. Calcium hydroxide. You see here, this is these two are reactants, quicklime and water, calcium oxide and water, reacting with each other, producing a product called calcium hydroxide, which is called a lime water. This is the lime water. This is the quicklime, and this is the formula of water. You see, these two are the reactants, and this is a product. You can see this is a product, right? Now this is a chemical equation, right? But the difference is, if you use their chemical names to represent shortly, if you use their chemical names, and this equation is called a word equation. It's called a word equation. Whereas if you use their symbols or formulae of chemical reaction, reactants and products, we call it as, it's a chemical equation. It's not word equation. It's a chemical equation. Chemical equation, right? So this is how we write chemical equations for various changes. Okay, let me write other. This is activity 1 that we did. Let's say activity 2. In activity 2, what happened? We added, what is it? sodium sulfate solution, sodium sulfate solution with a barium chloride, barium chloride, right? Sodium sulfate solution is added with barium chloride solution. So as a result, what did we see? We have seen a formation of a white precipitate, and that white precipitate is barium sulfate. It's right. It's a barium sulfate, and other one is sodium chloride. Sodium chloride, sodium chloride. Now this is a word equation for second activity. Then we write the chemical equation by replacing the chemical names with their chemical formulae. Sodium sulfate, sodium ion, sulfate ion, you can see, right? We can split it, sodium ion and sulfate ion. Sodium Na plus 1, sulfate SO4 minus 2. As a result, what is a chemical formula of sodium sulfate? Let's write. Chemical formula of sodium sulfate is Na2SO4. This reacts with barium chloride, BaCl2, gives rise barium sulfate. Its formula is BaSO4. You learnt in your previous class how to write the chemical formula, right? Sodium chloride, it's a NaCl. This is a chemical equation representing the chemical change. Okay. Now, coming to one more activity, the last activity, activity 3. In activity 3, what is added? A metal sample, a metal piece, zinc granules are added to hydrochloric acid solution, right? So, zinc granules are added. So, let me add zinc metal. Zinc metal is added to hydrochloric acid, to produce a salt, zinc chloride, and a colorless gas released was hydrogen, right? Hydrogen. So let us write this is zinc. Let us write their symbols or formula. Zinc metal, so we write only symbol. Its symbol zinc, Zn plus hydrochloric acid, HCl gives rise to zinc chloride, ZnCl2 plus hydrogen gas. Hydrogen gas is diatomic, we write as H2. So these are the chemical equations representing the respective chemical changes, right? First one is dissolving quicklime in water is a chemical change. Adding a solution of sodium sulfate to the solution of barium chloride, sorry, it is also a chemical change. Next, adding zinc metal to acid, hydrochloric acid, is also chemical change, right? And that chemical changes are represented in a shorthand way by using their chemical formula, okay, of reactants and products. So it is, we can write these are the forms of writing a chemical equation. So what is chemical equation? It's a shorthand representation of a chemical change. It's called chemical equation, right? And now let us see what is a chemical equation is, okay, right? Now we have learned how to write a chemical equation, okay, but now let's see how to balance a chemical equation. Let us see. Let me take an example of a chemical equation again, where hydrogen reacts with oxygen, right, produce water, okay. Then this reaction doesn't take place at ordinary conditions. It need extreme conditions of temperature and pressure, right? Where hydrogen gas, oxygen gas react with each other to produce water. Okay, this is a chemical equation representing the change, production of water from hydrogen and oxygen. Now, if you just look at it, hydrogen here, if you write a molar mass of hydrogen, it is 2 gram, and here this is 32 gram, okay. And if you sum up these two weights, 2 gram plus 32 gram, it becomes 34 gram. So 34 gram is a total weight, W1, total weight of reactants, or else we'll write WR, weight of reactants. Now, products, we know H2O, it is only 18 gram. This is weight of products is only 18 gram. Do you think all these two are equal? They are not equal. This is 34 gram, this is 18 gram. right? Weight of product that are obtained from hydrogen is only 18 gram, whereas weight of reactant substances are used there is 34 grams. It seems some amount of reactants get wasted. Is it really happens during in nature during a chemical reaction? It doesn't happen. Okay, it doesn't happen. Always the amount of products that are obtained, the total weight of the products, right, that must be equal to total weight of the reactants, reacting substances. Okay, but here it seems there is a difference in the weights, right? There is a difference in the weights. Such reactions do not take place. To explain this, a scientist, Lavoisier, mass of products, mass of reactant should be equal to mass of products. But is it happening in this reaction? Is it the same? No. Mass of reactants, total mass of reactant 34 gram, which is not equal to mass of products is 18 gram. So something is wrong, right? What is wrong? See, this is called, this equation, the chemical equation, which representing unequal weights of reactants and products, and they are called generally unbalanced chemical equations. Unbalanced